The Virtual Mechanical Fabrication Properties palette provides real-time ITM data, dimension editing, and advanced filtering tools for selected fabrication parts. For example, we can edit dimensions and specifications for multiple parts at once. Using approved submittal data, we can adjust dimensions and connectors for these taps. Here we can oversize the taps, adjust the length for the integrated OBD, and provide a 1-inch flin for easy installation. Using the VM Properties palette, we can edit dimensions and specifications for any fabrication part on the fly, as we model. This includes fabrication hanger dimensions, which are otherwise unavailable for manual editing. The Items property displays the quantity of selected parts, along with their name and CID. When multiple parts are selected, we can use the Items property to filter our selection. Each property on the palette functions in a similar way. Toggle buttons to the right of each property enable us to specify the function of each tool. In Select mode, we can filter our selections using the specified value. In Remove mode, we can remove the specified values from our selections. Edit mode enables us to set the fabrication properties directly. With the VM Fabrication palette, we can quickly and easily edit fabrication properties, or process multiple filters on our selections. This is a common task when working with tags and part numbers, or scheduling part data for various project requirements. For example, we can quickly select our entire welded threaded service, removing the gaskets, welds, and valves. For advanced, custom filtering capabilities, we can use the Selection Filter tool on the Virtual Mechanical ribbon. Specification changes are common enough, although they can be costly and time-consuming, especially when modifying existing coordinated services in Revit. Changing services while keeping the existing fabrication elements intact is only supported between services with identical templates and specs. Geometry changes are not allowed. We can, for example, change a service to a copy of the same service without issue. This isn't very useful excluding changing service name, since changing a service name in the database directly will bracket the service and orphan the parts. The only Revit-supported method for geometry modifying service level changes is to use the Change Service tool via the Modify tab. This will force a redraw and replace of the selected parts using the default items and dimensions of the specified service. As you can see, this can have wildly undesirable results, wiping out any data, custom dimensions, tags and numbers that existed on the original parts. Thankfully, in many cases where a service change is required, what we are really after is a specification or material change. Using the Virtual Mechanical Properties palette, we can do both. For specifications that are generally compatible, with only minor differences in gauges, materials, and pressure, changing spec is straightforward. In this isolated example, we were able to change a 4-inch water gauge spec to a 2-inch water gauge spec, with zero additional rework. For more significant specification changes, however, like changing a TDC spec to a welded spec, the parts will be disconnected and we must manually fix the mess that it makes. This is, however, a far better option when considering the alternative that Revit provides. In the event that a spec change creates an unacceptable inconsistency with the service name, we can perform a copy and rename of the specified service in the fabrication database profile, then change service before changing spec, as previously mentioned. The Virtual Mechanical Properties Elevation tool has existed since Revit 2018, when top and bottom elevations were unavailable for fabrication parts. In Revit 2020, these elevations were added, however in most cases, the VM elevation property functions much differently. Both tools are useful, and knowing the differences between these tools will help us to make our elevation changes and calculations much easier. One of the more obvious differences between the tools is that the VM elevations do not include insulation, while the Revit elevations do. In many cases, the Revit properties will not allow us to modify top and bottom elevations directly. With Virtual Mechanical, we can. When making elevation changes with the Revit properties, risers and vertical offsets will be stretched to maintain connection. When making elevation changes with Virtual Mechanical, any elements excluded from the selection will be disconnected. It is a common requirement, especially in the early stages of coordination, to move entire systems up or down, without changing their overall structure. The Virtual Mechanical Elevation tool introduces the concept of highest and lowest elevation to fabrication parts, helping to manage elevation changes to large selection sets. Here we can see that the lowest elevation of the selected roof drain is 12 feet, while the highest elevation is almost 16 feet. Using the lowest or highest elevation option, we can make relative elevation changes to entire systems at once, without changing their overall geometry. This can even be done when multiple services and fabrication categories are selected. With the VM Fabrication Palette, we have instant, real-time, read-write and filtering access to our fabrication data, including status, cut type, bought out, product entry, and much more. Leveraging powerful, intuitive tools like these, Virtual Mechanical helps to make our Revit fabrication workflow much easier.